Hey guys, and good morning. So I hope you watched up to minute 6 of this video because this guy introduces terms that I intend to use in the rest of this class. So it's important that you watch that. If you didn't, please stop this video and then go back and watch up to minute 6. Then you come back and watch this video. So he talks about terms like monomials, binomials, trinomials, and polynomials, and gives explanations for each of them. Today I want us to talk about the trinomials, right? A trinomial, because a trinomial is a three-term expression or a three-term polynomial. And in mathematics, polynomials that have three terms are called quadratic expression. And each of these three terms have different powers. So for example, the biggest term has a power of 2, the next biggest term has a power of 1, and the last term technically has a power of 0. But I hope you remember that anything to the power of 0 is 1. So this expression is just 3x squared plus x, because 1 times x is just x. If there's a 1 in front of anything, 1 multiplied by something is still itself, minus 5. So this is our focus for today, quadratic expressions. If an expression or polynomial has three terms, it's a quadratic expression. You will find some books generally writing quadratic expressions like this. And I know you can see that this is letters, squared, and x's, and what, and you can start like getting shivers or like getting panic attacks or all of those things, but please don't let any of this scare you. It's just numbers that are in place of letters, because there's a trillion numbers that could go there, or like infinity numbers that could go there, but instead of writing all those numbers, we just represent them with letters. Anyways, so this is our focus for today, quadratic expressions and how to simplify them, how we can do operations like addition, subtraction, multiplication with quadratic expressions. That's our focus for today, and that is simplifying quadratic expressions. So I'll start off with a simple example. How can I simplify this quadratic expression? Remember, as soon as you see a power squared in any expression, as soon as you say power squared, so for example, if I have 2x squared, this is already a quadratic expression because the highest power is squared, right? As soon as you see the highest power being squared, or power 2, it's a quadratic expression because you know that there are other terms here. For example, there is 0x to the power 1, and there's also 0x to the power 0. There are other terms there, they're just invisible, you can't see them, or they are hidden terms because their coefficients are 0. And I hope you remember what the word coefficient means. It's just the number in front of a variable, the number in front of an unknown. So these variables are 0. That's why those terms are not seen in this expression. But as soon as I see that something is squared, I know that that's a quadratic expression. So this is an example of a quadratic expression, right? And this is one quadratic expression. It can be added to another quadratic expression. So that's what we have. You can also have your quadratic expression of just 2x squared plus 1, right? This means it has the quadratic term and it has the constant term, because if I didn't tell you here, this term that has the squared is normally called the quadratic term. This is called the quadratic term. This normally is called the linear term, right? Linear term, or the monomial, the linear term. And this normally is called the constant term because it's just a constant number. So you have a quadratic term, you have a linear term, and you have a constant. Let me just write them out. Quadratic term, you have a linear term, and you have a constant term. Those are the three terms of a quadratic expression: quadratic, linear, and constant. So, and some people call it the square term, this one. Some people call it the square term, but it's fine. You can call it linear term, or quadratic term or squared term. And I hope you are writing these things down in your notebooks. Okay, so here we have a quadratic expression in which we have a quadratic term and we also have a constant term. This simply means that the linear term has a coefficient of 0, and that's why it's not included, right? That's simply what it means. So it's still a quadratic expression. Or you could just have your quadratic expression as a full thing, 2x squared plus say 3x plus 1, where you have everything there. This is just obviously a quadratic expression, but as I've told you, all of these others are also quadratic expressions. If it's just 3x, this is not a quadratic expression, this is a linear expression because the power is 1. So don't confuse that with a quadratic expression. So if I want to simplify this quadratic expression, I just need to look at the terms. This term is squared and this term is squared. What does that tell me? That tells me that they are like terms, right? Since they're both squared, they are like terms. So what do I do with like terms? I can add them, I can do whatever I want to them. Because if I have a cow here, a very nice looking cow. Ooh, cow with 4 legs. And I have another cow here. Cow, 4 legs. Wow. Anyways, since these are both cows, I can just say I have 2 cows, right? I have 2 cows. I can just add the cows and say I have 2 cows because they are like terms. They're both cows. I can add cows. But if it was a cow and a goat, I'm not going to draw the goat because I don't know how to draw a goat. If it was a cow and a goat, I wouldn't be able to add a cow and a goat and say I have 2 goat cows or 2 cow goats. I would just say I have a cow and a goat because I can add them. So these are like terms. So think of this as a whole cow, right? And this as another whole cow. So this person has 3 of these whole cows, and this person has 2 of these whole cows. So what I do is I just add the 3 cows plus the 2 cows, and I get 5 cows. So it's 5x squared. Moving on. Now I have 3 cows, and I'm subtracting 1 cow because I hope you remember that if there is nothing in front of the unknown, then that number is a 1. So I have 3 cows subtracting 1 cow, so that's just going to be 2 cows, right? Where when I say cow, I mean x squared. So that's just 2x squared. Another example, I have negative 2x squared plus 5x squared. Again, this term is the same as this term because they're both squared terms. So I'll just add the numbers in front of them. So I'll just add negative 2 plus 5. And I know negative 2 plus 5 is 3, so my answer here is 3x squared. Moving on, look at that. X squared, the terms are the same. What do I do to the coefficients? I add the coefficients. So this is just negative 4 minus 3, which gives me negative 7 of cows. I don't think you can have negative 7 cows. It's just negative 7x squared. Wow, this is a big one. I have 2x squared. I just need to look for the like terms, the terms that have the same powers. So I have 2x squared and I have 4x squared here. Those ones have the same powers. And then here I have 3x and 5x also have the same kind of unknowns, the same powers, the same variables, because this is power 1 and power 1, and this is power 2, and that is also power 2. So I'm just going to rewrite it and say this is 2x squared. I'm going to write it with its, cow friend, 4x squared, negative 4x squared. Then I write negative 3x plus 5x because also those ones are, call them God friends. So this is 2x squared minus 4x squared, the same term, x squared. So what I do to the coefficients is I add them. So I'll have 2 minus 4, which is negative 2x squared. And then this is negative 3 plus 5. This is a goat, and that's another goat. So I have negative 3 goats plus 5 goats. It's just negative 3 plus 5, which is positive 2 goats. So I finished. They asked me to simplify, so I can stop here. They didn't ask me to factorize. I'm going back one step. The progression should have been from, because we did factorization last week, and then we should have progressed on to expansion. But I thought I'd first tackle this idea of the quadratic expressions and what they mean, so that before we move on to expansion. Alright, so simplify this one. Let's see, I have a cow here, I have another cow here, i.e. x squared, right? And then I have a goat. I have a goat here. I only have one goat. And then I have some chickens. I have this chicken and I have this chicken. So the like terms are this cow and that cow, so I'll collect the cows together, so I have negative x squared minus 2x squared. Very good. Then I'll look for the goats, so just 4x, and then finally plus 2 plus 3. So negative x squared, this is like negative 1x squared minus 2x squared, right? It's negative 1 minus 2, that gives you negative 3x squared. And then plus 4x, this is the only goat element I have, so there's nothing I can add it to, so I'll keep it the way it is. And 2 plus 3, 2 chickens plus 3 chickens is just 5 chickens. So that's my simplified expression. Next one, again, look for like terms. 7 is a constant number, 4 is a constant number. So those ones will combine. And actually, at some stage, you'll get so good at this that you'll start doing it in your head, and you just tell yourself, well, this is a positive 7, and that's a negative 4. So 7 minus 4 is just 3. And you say, I've finished taking care of those ones. Now, moving on to the next ones that I haven't yet taken care of, you can say, this is a negative 3, right? Negative 3x, so negative 3 goats, and negative 2x, they are like terms. Negative 3x, if I add it to negative 2x, I'm going to get negative 5x. Then you would say I've also taken care of those two. And then finally you'd be left with positive x squared and negative x squared. And if you know anything about all of the math you've been doing, is that if I have a positive and a negative of the same number, they just cancel out, because this is positive x squared and that's negative x squared, so they'll just cancel out to give you 0. And then your final answer is just 3 minus 5x. Let me just do this in a more detailed way. Collecting like terms means that you pull the ones that are constant next to each other. Then you have negative 3x, and then you want to bring the one that's like negative 3x, i.e. the same term, a common term, a similar term next to it. And then finally plus x squared minus x squared. So 7 minus 4 is obviously 3. Negative 3 minus 2x, and this one, honestly, think of this x and this x as common terms, right? If they are common, then they're representing the same thing. It's like negative 3x, 3 goats and 2 goats, but these numbers are negative, so you just take the two, you deal with the two negative numbers. It's honestly as if you're just doing negative 3 minus 2, which is negative 5, but they are representing a variable known as x, so then I'll put the x. And then finally here, x squared minus x squared is 0, so your answer is still the same. So I encourage you to practice and practice such that you get to a stage where you can simplify these things without having to write out a lot of things. So, and I'm going to practice that here. I only have one term that is 4x. So I know that in my simplified version of this whole expression, I will only have one linear term, which will be 4x. Then I have 3x squared and I have 5x squared. This 3x squared has a negative in front of it, so it's negative 3, and this is positive 5. So negative 3 plus 5 is going to be positive 2, but it's all x squared. And I finally have 1 and 2. The 1 is negative, so negative 1 plus 2 is just positive 1. Yeah. Alright, so my challenge for you is, how would I simplify this? We've seen in so many of these things that if I have a number in front of x squared and another number in front of x squared, it's basically as if the final answer is an addition of those two numbers, because those are like terms, right? That's what we've seen. So my question is, how would I simplify this? Like, well, if I wanted to write some kind of answer here for this, what would it look like? What would it be? And what steps would I go through? Pretend as if A and B are any random numbers, as if they are normal numbers, like maybe 10 and 12 or whatever, any numbers. How would you simplify this expression? This is what I want you to let me know in the comment section. Start your answer with hashtag challenge question. And this is mandatory for your participation grade. Alright, and finally, this is your homework. Try it one on page 40, try it two on page 41, and those questions on page 45. You can check your answers on page 201 of the textbook. Check your answers. This doesn't mean that you go and copy the answers. I just putting it there so that you can check if you're right before you submit. So I don't have to cross you and send it back. Okay, that's it. Bye.